Thank you. Hopefully everyone can hear me. It's nice to be back again this year. In fact, the topic of this presentation is something that actually occurred about a month after I got back to Seattle. And so hopefully you can learn from some of the lessons we've learned at Microsoft. What I'm going to talk about is what it's like to be in the room when there is a software supply chain attack going on. And the attack I'm going to talk about, for the most part, isn't one that focused on Microsoft. It was actually one that focused on the Node developer community, or the JavaScript developer community. So I'm a program manager at Microsoft, and I actually work on a team called the Azure Artifacts team. And the Azure Artifacts team operates one of the world's largest artifact repositories. So what I mean is software engineering artifact repositories. And what that means is that we have a fair amount of responsibility for keeping the software that Microsoft gives to its customers safe, but also keeping the software that customers produce for themselves safe as well. In fact, does anyone want to guess at the volume of data that we store in terms of artifacts? So think build outputs, packages, that kind of stuff. Anyone want to take a guess? Some petabytes, yep. How many? 12. At least 10 times. We actually store about 155 petabytes of artifacts. And most of that is actually for Microsoft, and then some of it's for our customers. Microsoft produces a lot of software. So when we have a supply chain attack, a software supply chain attack, we're very interested in what happened and how it occurred and protecting against it in the future. And so this is one that occurred to the Node.js community as a whole, but Microsoft was also impacted, and we've also had focused attacks on Microsoft in the past as well. So as I said, the attack that I'm going to talk about in this instance occurred about a month after I got back to Seattle from FrontCon last year. On July 12th, 2018, a hacker or an attacker managed to grab a stolen username and password for one of the eslint maintainers. So if you remember the eslint vulnerability or malicious package from last year, this is the issue I'm talking about. Now, in this particular instance, the maintainer perhaps used the same password for npm.js as they did from the other site where the password was stolen from. Tip, if you're going to build your own security system, at least hash the password and add a salt. It can stop these kind of, not only could the password have been stolen in a hash form and then discovered via a rainbow table, you could have mitigated that attack by using a salt. But using authentication services and so on is also a good idea. So at about 9:49 UTC, the hacker actually used those credentials to upload a malicious version of the eslint-config-eslint package. And this was a precursor to their attack. What they did with this package was they inserted a post-install script. And that post-install script would go out to a pastebin website, download some code, and execute it on the local machine. And what that code did was actually lift the npm credentials out of your global npm-rc file. And so the idea was that the attacker could actually then use this to start to compromise many more packages. So, and in fact they did. There was, in some of the analysis that followed this by npm, they found some other packages that had been compromised using identical code and some that were compromised using similar code. Now, at 10:40, the hacker actually uploaded another package, eslint-config, and it had the same malicious code. I think the idea was that they just tested on that first package upload, and then they grabbed another package which was a little bit more common. At about 11:17 UTC, so this thing had been in the wild for a couple of hours, someone actually notified the eslint maintainers that the package installation was doing something funny. Basically, an error occurred when they installed the package, and the person who installed the package observed the error and reported it. To be honest, I think that the Node community, the JavaScript community, was lucky, because if the hacker had actually written their code better, this would have gone undetected for much longer. And the issue would have been very difficult to clean up. At about 12:27 UTC, the pastebin that contained the malicious code was removed, which means that the attack was at least partially mitigated. Now, if I was the hacker, I would have actually put in some fallback logic into the malicious package, so it wouldn't have been that easy. But I think you've got to think like a certain kind of person to come up with those techniques. So once again, I think the community was pretty lucky. At 12:37 UTC, the NPM team took down the malicious packages, and they were notified to do that by the eslint maintainers. At 12:37, the eslint maintainers published a new updated version of the eslint-scope package. Now, the previous package, the eslint-config-eslint package, was actually removed by the attacker themselves, and so they didn't need to worry about replacing that one. The reason for doing this was that eslint knew that there were some consumers of these packages which automatically just updated whatever version of the package was being consumed, and they wanted to make sure that they got a clean, known, good version of the package into people's local installations. That's a whole other story about why people automatically update their dependencies blindly. At 1842, after some analysis, the NPM actually revoked all of the access tokens created before that date. So on July 12th, you probably would have noticed, hey, I can't publish my packages anymore. You would have had to have regenerated your tokens. And that was a global action they took. If you want to read a synopsis of the post-mortem, which was done by the eslint maintainers, by all means have a look at that URL. It goes into more detail and there's lots of links. So all good, right? No problem. Problem solved, threat mitigated. Well, not quite. Even though NPM had revoked the access tokens for the public registry, a lot of people had private registry tokens in their npm.c file, and those tokens were potentially also stolen. At this point, there wasn't a thorough analysis of the malicious code, and so people who were running private registries like Microsoft didn't really know exactly what the potential damage was. It turns out that after some later analysis, a bug, once again, in the malicious code actually meant that private registries generally wouldn't have been affected, but we didn't know that at this point in time. So when I talked through the reaction steps we did, keep in mind that we didn't know, by the time we knew about the vulnerability, the malicious code had actually been swept off the internet, and it was hard for us to find a copy of it that we were confident was the only copy that was around. So we became aware of this sort of later on the 12th of July. We started working on understanding what the blast radius was before we took any particular action. Once we knew what the attack was, we immediately looked at our telemetry to figure out which customers of ours had actually downloaded the malicious package through our service. We did a couple of things. We revoked all of the tokens for users in that organization. In fact, the tokens that we were talking about were JORT tokens, so it was a good timing. And so we had to go through that process, and we had some limited capabilities to do that. Now, that's the first sort of radius of the blast radius. We then thought about it some more, and we thought that there's probably some users that might have downloaded the malicious package directly to their local machine, not via our service. And because we didn't know how the malicious code worked at this point in time, we thought it was possible that also, even though we may not know from our telemetry that someone may have been compromised, they may have been compromised indirectly. And so we realized that we actually had to consider revoking all of the packaging scope JORT tokens for the service. And then we know from experience that some of our customers use different access token types, so PAT tokens. Think of a PAT token as a pointer to a JORT token in our service. And some of those tokens are pretty privileged. People will create them with what's called a global scope, which means that you can use that token to attack a much larger API surface area. At this point, we're thinking, what do we do? So once we understood the blast radius, we had to think through our obligations to our customers. And the question we had in our mind is, should we or will we revoke all of the tokens for impacted organizations? So what would you do? Who, put your hand up if you would revoke all the tokens. Couple? And so who wouldn't revoke the tokens? Okay. So for those people who said, would you revoke the tokens? And you said yes. Are you really sure? Okay. Let's do some math. So I'm going to focus on the Microsoft scenario. Microsoft's got a lot of software engineers. They're the Azure Artifacts team. Microsoft is its own biggest customer. And so I'm going to talk about Microsoft here, but you can apply this same math to other organizations. So Microsoft has about 94,000 software engineers, or people in an engineering role. And let's say, conservatively, 1/3 of those were impacted by this incident. So if we revoke the tokens, 1/3 of the engineers in the company would be impacted. Either they'd have to replace their tokens locally, or the build systems that they rely on would be impacted for a day, as people sort of scrambled to understand what the issue was when their builds started breaking. Now, don't get me started on why people's builds should be so fragile to a token being revoked. That's a whole other issue. But we just knew that when we revoke these things, there's going to be a splatter effect. Now, let's say that every engineer earns or costs the company about $500 a day. That's an underestimate. All right. This was a greater than $15 million decision we were making, just for Microsoft. All right. So we're sitting there in a room, we're a relatively small team, and we're deciding, are we going to cost Microsoft $15 million today by revoking these tokens? So how are you feeling about that decision now? Who would still say revoke the tokens? A few less people.
What's written in the terms of contract?
Sorry?
What's written in the terms?
Written in terms? Well, that's right. And so what's the consequence of revoking? What's the consequence of not revoking? That's kind of where we landed. Now, you've got to make that decision not just for Microsoft, but also for your customers. So we've got some customers that have several thousand software engineers, and we're about to go and revoke their tokens, and that's going to cost that customer potentially millions of dollars in lost developer productivity. Generally, as a service provider, you don't want to do that to your customers. So this was a difficult decision to make. In the end, we decided to revoke the tokens in a progressive manner. We actually had two problems. We had an engineering problem. We actually had to come up with a way of efficiently revoking these tokens at that sort of scale. And we also had to understand which customers we needed to communicate to. Now, we're in Europe here. So you guys know all about GPDR? GDPR. Thank you for that. It's the engineering teams at Microsoft had a lot of fun implementing and complying with those policies. What it meant was that our telemetry window for understanding which customers had accessed the service within a certain period of time was limited. And there are some sort of rules about how you can use that data for security situations, which are a little bit different. But it meant that we had to do some digging to figure out which customers we needed to reach out to revoke tokens. Because we didn't want to revoke the tokens for everyone if they've never touched NPM in our service, for example. But we didn't want to miss anyone either. So we had to do some data mining. And so we learned some lessons in the, overall. So we went through the process, we communicated with our customers, we actually went to build an entire feature to allow the customer to self-service revoke tokens if they wanted to revoke faster than we were going to revoke it for them. So we gave customers a bit of a window. And so we did that and the job was done. But we've learned a couple of lessons along the way. First of all, this was a simple little package, right? But software supply chain attacks actually have a surprisingly large blast radius. In a lot of ways, an attacker gaining persistence on a server in production has less blast radius than them attacking your build system for shipping your software. Part of the problem is actually understanding the blast radius itself, because you actually have to have really good understanding of what the malicious package does. And when you're in an open source community where a lot of that information vaporizes by the time you're actually realizing there's a security issue, you don't necessarily have all of the information you need to make decisions. And then when it comes to decisions, we start thinking about these $15 million questions. Teams like ours need a framework to say, well, how do we think about addressing this particular threat? Now, Microsoft being such a small company, We've got teams of people that specialise in this kind of work. So we were able to engage an internal incident response team, and they actually helped us reason through some of these decisions. So we consider ourselves lucky. In your case, I would at least write down a plan. What happens if one of our packages get compromised and it gets into production? Have a think about what your response is going to be as an organisation. Because when it happens, sometimes it's hard to think straight because you've got these big numbers floating around. The next lesson we learned was that actually reacting to the mitigation of the attack itself can be costly. We actually had to repurpose an entire dev team to actually build a feature. Now, we had planned to build a feature like this anyway, just as part of just general improving the security of our service. But we had to bring that forward, and all of the work that team had been working on for that sprint kind of had to get put aside while we addressed this. But not reacting can actually be more costly. And that's kind of why we ended up taking this decision. And that gets us to probably a really important question, is how do we prevent this in the future? So there's some practical tips for package authors, right? Don't reuse passwords. In fact, that's advice for everyone. Don't reuse passwords across websites. It's just a bad idea. Consider using special accounts for publishing packages. So if you've got a popular Node.js package or NPM package that half the planet uses, don't publish that with your regular NPM user account. Right? Have a special account which is completely isolated, which you only ever use when you're interacting to publish with NPM. And that just helps reduce the potential for attack. And then secondly, use 2FA whenever you can. Now there's a couple of issues here around automated release cycles and that kind of stuff with 2FA, and that's one of the reasons why you might want to use a special account that you don't use that often. So your primary account does have 2FA, and your special account may not, but your special account is only ever used in your automation system, for example. But there's other processes you could use, like where you insert a 2FA token on the fly as you're going through the publish process. Now, here's the question. Do you trust the 1,018 package authors for your React apps dependencies? This is a real number. I checked it this morning. I did create React app, and I did an eject, and that's the number of dependencies. Now, I actually trust the React guys. I think the create React app is awesome, and I think they probably think carefully about what they include in that application bundle. But that's a lot of people to verify doing this properly, doing that previous list properly. And so really you've got to do some things as a consumer of packages to make sure that you're keeping yourself safe. So the first thing is make sure you use a lock file. Who can say that all of the Node.js modules that you've got in a Git repository have a lock file today?
All the dependencies?
All the NPM packages that you've written, do they have a lock file? Who can say every single one does? All right, you should go home and change that tonight after the party. Usually after a few beers, it's much better to do coding. So if you use a lock file, that does a lot to mitigate a lot of the threats in your engineering system. Whether you're using Yarn or NPM, or even for your server-side code of using .NET and NuGet packages, they have lock file support as well. Most of the modern package managers have lock files. Use them. In fact, newer versions of NPM spit out the lock file by default. Yarn spits out the lock file by default. Check it in and rely on it. One of the other things that happened with the eslint issue was that there were some teams that were taking dependencies on the eslint packages, which were automatically merging them into their code bases, and then basically sending that dependency upstream into their other NPM packages that they were publishing. So they were actually just automatically merging whatever was published on NPM. And so it actually made the threat spread just a little bit. Fortunately, the community reacted pretty quickly here, and so the threat was mitigated pretty quickly, but it could have been much worse. And whenever you do an NPM install, always watch for dependencies which are updating. Be inquisitive. If you've got a package that's gone from version 1 to version 1.01, open up the packages and see what's changed. All right? It might just be a 0-day attack in progress. Your dependencies, particularly if you're using lock files, shouldn't update that often. And so when it does, it's always worth taking a second look. And then finally, when you're dealing with registries, whether it's the public npm.js registry or another private registry, use tokens which are as restrictive as possible. If as a developer you're not the person who's responsible for publishing to a registry, don't use a read-write token in your local npm-rc file. Make a read-only token. There's generally ways of doing that. Now, this is not just about the package authors, and it's not just about the package consumers. People who operate private registries like our team also had some lessons to learn as well. We needed to provide self-service revocation options. Now, we actually had this. All right? We had the ability for a user to go and revoke their own access tokens. The problem with that is, though, that let's say you've got an organisation which has 94,000 software engineers, going out to that company and saying, hey, all of you 94,000 people, go and revoke your tokens. The chances that those people are actually going to look at that email and respond to it and do the right thing is actually pretty low. And so the feature work that we did was actually enabling administrators to basically go and revoke people's tokens on their behalf. They don't see the token, but they can basically pull the tokens out of circulation. So a way of forcing it from an administrative point of view. And the next thing we did was make sure we had a quick package blocking mechanism. So if there was a package that was malicious, and let's say that the NPM community didn't react as fast as they did, on our service side, we wanted to be able to put the locks on that package fast so that our service couldn't be used to spread it. Now, when I talk to people about vulnerabilities, sometimes they say things like, it's okay, we use scanning tool X, so we don't need to worry. Well, I think there's a misunderstanding with this. The misunderstanding comes from the fact that there's malicious code and then there's vulnerable code. Vulnerable code is code that was not necessarily written with malicious intent, it's just got some coding errors in it. And so those vulnerabilities can be identified, they can be listed and reported, generally long after that package has been released. And so you can scan your code base to identify those vulnerabilities. You should take note of that and address it. But malicious packages are actually much more insidious because a malicious package, like we saw with the eslint issue, is published on a day and it goes active that day. And so none of the public vulnerability databases are actually going to help you in this instance. None of the private vulnerability databases are going to help you within this instance unless those databases are like super on the ball listening to the community about these issues. So make sure you understand the difference between the two. Now, I'm going to do a little bit of a demo here. I sort of don't have a lot of time, so I'll whip through it pretty quickly. I'm going to talk about some of the things you can do, particularly when you're operating with private repositories to protect yourself against zero-day issues. Nothing's bulletproof. Zero-day issues are actually very hard to protect against, but this might at least improve your posture somewhat. So the scenario is going to be pretty straightforward here. What we've got is I'm not sure if can I draw on the screen here? Display settings. Just give me a second. Okay. So what we've got here is a pretty simple situation where I've got a developer and I want to use a new package in my code base. And so I install that package from the npm registry. So this is sort of step one here. And then what I do is I make sure my code's all running locally. At this point, I could have actually been compromised. Right? This could have been a malicious package unless I took the extra effort of downloading it, not as a npm package, but as a TGZ file, unpacking it, looking at the code, and comparing it. Who's going to do that? Right? No one does that. So at this point, as a developer, assume you could have been compromised. So then I'm going to submit a pull request. And what's going to happen is that pull request is generally going to trigger some kind of pull request build. Now that pull request build is going to pull those packages, all of your packages from a private registry. Now, the way our private registry works is that you can tell it that I've got a feed, and that feed also points to npm.js. So if I go and install something like moment.js, it will actually pull it down from npm into our private feed and then onto the build machine. So it's a way of propagating it down. And then once that build completes successfully, that pull request can be merged. And so we have, a set of packages sitting in my private registry here. And I approve my pull request. Now, when I approve my pull request, we're going to trigger another build. But that build's going to fail. And the reason it's going to fail is that I've configured my CI build to pull from a subset of my private registry, only pull from the set of packages of which I approve. And the reason we do that is that the CI build is something you have to protect. Assume that a PR build is compromised, because people can put whatever code they like in there. So you have to assume that that's dangerous anyway. But your CI build is what ships to production, potentially. And so you have to protect it. And so in addition to approving the pull request, what you need to do is also approve those packages into the approved view. And this is your opportunity as a developer, someone who cares about zero-day issues, to inspect those packages that you're moving across. It's an extra step in the pull request process. It's a little bit tedious, but if you want to protect yourself from zero-day issues, it's something that I would recommend. So let's look at this in practice. So here I've got my my build environment, and here I've got a repository. I'm just using Azure repos here, but GitHub works just as well for this scenario as well. I want to point out a couple of things. The first is that you'll notice my npm ignore file. My npm ignore file ignores everything. So one of the things that may have happened to you, and you should probably go and check the packages that you published, is if you have files in your directory that you publish from, they may contain secrets. And unless you ignore everything, you may accidentally slurp some of those secrets up into your packages and publish them into public registries. So keep an eye out for that. I did this the other day accidentally. And so I had to go through a whole process of revoking tokens and so on. In fact, I ended up filing a bug on our team because I felt that it should never have happened. And then you explicitly include just the things that you want. So you're saying ignore everything, but then don't ignore index.js, don't ignore the README, don't ignore the package.json file. It gets a little bit harder when you webpack things because you get these random file names. There are ways of dealing with that. The next thing I do is I have an npm-rc file. Always put an npm-rc file in your registry. And the reason you do this is it stops you shooting yourself in the foot. And I'll come back to why that's important a little bit later. And then I just have a build definition. And what I do in the build definition is, depending on whether I'm running on the master build, oops, I've lost my network. Oh, there we go. Depending on whether I'm running on my master branch or I'm running on like a PR branch, I just insert a different registry. It's a bit hard to read, I'm sorry about that. Okay. So, make sure you do a PR process for everything. Don't let anyone commit to master because that's where zero-day packages can get in nice and easily. When you ingest external packages, do it via upstreams, and you can do it in your PR build if you do it at all. If you want to be super secure, you would never ingest any packages via an upstream. So there's a balance to strike here. And then consider manually inspecting and promoting packages. So you can go into your view here, and if I go across to my package list here, I can actually promote this into an approved view, and then that build will actually work. The other thing you should do is use the npm CI command. Who uses the npm CI command? Who knows about it? Okay, the npm CI command is awesome. So assuming you've got a lock file, the lock file contains not just your immediate dependencies, it contains your transitive dependency graph. And so when you're doing your npm install on your CI server, npm CI will actually run faster than npm install because it doesn't have to traverse the dependency tree. So if you want to speed up your build, use npm CI. The nice side effect is you have to use lock files. So that's awesome. And then use your npm ignore file to avoid exfiltration. Now, let's talk about the npm-rc file and why I said that was important. The eslint issue was a fairly broad-based attack. They're basically saying how many tokens we could get, and I'm assuming they would get those tokens and later on try and figure out how to exploit them. But you can actually do much more targeted attacks with packaging ecosystems if people aren't careful. Microsoft has been a subject of these attacks. You know, we've detected them successfully, but they're pretty scary and they're quite effective. So who creates their own private packages and hosts them in their own private registry? A couple of people? Okay, let's play a scenario out. So I'm assuming if you're using a private registry, you're familiar with this command, setting up your registry. Coincidentally, if you use a npm-rc file, this command doesn't do anything. And then on a new machine, you probably do something like this. You go git clone, grab your repo, npm install and code. And on a good day, that just works. But every now and then, people forget to set their registry and you see something like this, which is cool. Oops, I forgot to set up my registry. So you do that. But what if you don't get that error? You haven't set up your registry and you don't get that error. What's happened? See, what can happen is that someone, if they know what the name of that package is and what the version is, they can use it to attack you specifically. They can publish that package name and that particular version into the public registry and insert the malicious code into it. All right? Who actually squats on their private packages in the public npm registry so that can't happen? No one. It's not a common practice. Microsoft does it in a few instances. Not for npm, we do it for NuGet actually. In fact, on NuGet you can't publish a Microsoft.something package for this reason. Right? Only certain people at Microsoft can do that. So if someone knows the name of your private package and they know the version you rely on, they can set a trap for you if you're a forgetful developer. And there's really just two things you need to do to mitigate this attack. Put an npm-rc file in your repo and use a package lock file or a yarn lock file. And that will effectively mitigate that attack. It'll effectively mitigate that attack for two reasons. First of all, when you do your installation of your packages, it will try to hit the private registry, not the public registry, even when you forget to set the registry value. So at worst, you'll get an error to say you need to authenticate. But the lock file will protect against someone substituting the content. And so that's why you also use the npm CI command locally as well, because it won't attempt to rewrite the package lock file when you install those dependencies. So one final thought, and then I'll open the floor for some questions. Will humans always be required to detect zero-day malicious packages? One of the things that we've been thinking about on our team is how can we mitigate these attacks? And I think it's hard. I'm not sure that we'll ever get there where it's completely automated, but I think there are a few things that we could probably do. You know, I think that first of all, as a community, we need to better integrate the package consumption with code review process. So I think that packages and code need to be evaluated the same way in the pull request process. At the moment, a package is kind of dealt with as this sort of opaque lump of dependency that you don't look inside. I think that needs to change. And when you get the ability to look inside it, we need to understand how to compare the package you're consuming with the previous known good version. And maybe there's something here where the community needs to start maintaining a registry of known good baseline packages and being able to look at the delta between the two of them. And then, I think that, taking that one step further, I think that when people want to create trusted, verifiable packages, they also need to provide code that exercises those packages. And when they do that, we could run that code inside a blast chamber, and the blast chamber would detect what that code is doing and report, hey, this package is accessing this file, or this package is trying to go across the network. And all of that heuristic information is fed back to the developer before they approve the pull request. And we get a better idea of, you know, what is this code really doing? Now, if we said, look, let's just outlaw post-install scripts, the attackers would just move their code into the main body of the malicious package. So that's not an effective mitigation. You can do an npm install and ignore scripts, but if everyone did that, it wouldn't actually be a good long-term solution. Hackers would just work around it. So I think that for now, zero-day malicious packages require manual inspection. Every single time you see your dependencies changing, I think you need to take a closer look. But I'm hoping that we can start to augment that decision-making process in the future. I think it's going to be a really interesting future for the way that people manage their artifacts. So with that, I've got a couple of minutes left, so I'll open it for questions.
All right, who is paranoid now?
All right, thank you for making everyone paranoid. Just a quick question. Do you think something like maybe a build signing or mandatory two-factor authentication before publishing would help with these sorts of situations? Or what can NPM basically as an organization do to help with that?
Yeah. So one of the things that came out of the post-mortem was that if the developer who... Now, I don't blame the developer. I mean, it was just a mistake, right? And people make mistakes. I'm sure they'll never make it again. And this isn't that wasn't the only incident last year. There was the event stream issue that occurred last year as well. But to answer your question, 2FA would have helped mitigate this issue. But it's possible that depending on how the tokens work, people could potentially still compromise, get a malicious package up there. Package signing is another interesting thing. Package signing is being looked at a lot by a lot of different package managers, and it's a complex thing. The problem with package signing is that for the same reason people seem to have trouble authoring packages in a secure way, they tend to have trouble managing the signing keys in a secure way as well. So all you do is you end up producing a set of packages which people trust more, but are not necessarily any more secure. And you probably recall in the news recently, ASUS produced a... Who's on a ASUS laptop? Have you rebuilt it this week? You should probably check. So I've got a ASUS motherboard, so I checked on my dev workstation at home. So what happened there was that the attackers managed to compromise the engineering system pre-signing. And so the firmware that was getting rolled out was signed. So signing is not necessarily a solution in itself. All it proves is that the code you're running came through that engineering pipeline. Doesn't necessarily mean that it's secure. Doesn't mean that the vendor's not saying it's secure, they just didn't realize that they've been compromised. Okay.
More questions to Mitch? Or just everybody's just anxious to look at their dependencies and add JSON log files.
Package lock files, npm-rc files. Go and do it straight away. It's very important. You'll save yourself a lot of pain in the future.
All right, then thanks, Mitch.
Thanks. Cheers.